Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Generative Adversarial Networks. GANs. The AI art forgers, two ICE playing a game of cat and mouse to create incredibly realistic fakes. Analogy. One AI tries to create perfect counterfeit money. The other tries to detect it. Welcome to the fascinating world of generative adversarial networks. Our GANs. Imagine a sophisticated game of cat and mouse being played by two highly intelligent ICE. Our main topic today is how these two ICE collaborate and compete to create incredibly realistic fakes, whether it's images, music, or even text. Think of it like one AI trying to create the most perfect counterfeit money, and the other AI acting as a super smart detective trying to sniff out those fakes. Their constant struggle makes both of them incredibly good at their jobs. Let's break down the name, Generative Adversarial Network. As a developer, you're used to writing code that does things. This AI is about creating things. Generative. This means the AI isn't just analyzing existing data or categorizing it. It's actively generating new, original data from scratch. Like a developer writing code to generate a new game level or a unique user interface, but here, the AI generates something like a new photograph of a person who doesn't exist, or a never-before-heard song. Adversarial. This is the game part. It means there are two AI components, and they are working against each other in a competitive setup. This adversarial relationship is what drives their improvement. Much like two rival software teams pushing each other to build better products. Meet the first player in our game, the generator. From a developer's perspective, think of this as a function or a module in your code whose job is to take some random input, like a string of random numbers or a noise vector, and transform it into a piece of data that looks real. Analogy. This is our master counterfeit artist. It starts with nothing but a blank canvas or some random scribbles, and its goal is to paint a picture, or create an image, or a piece of audio that is so convincing it could fool anyone. It's constantly trying to improve its forgery techniques. Now, meet the second player, the discriminator. If the generator is the artist, the discriminator is the art critic, or our vigilant detective. Analogy. This AI's job is to look at a piece of data and decide if it's real, an authentic image from a dataset, or fake, an image created by the generator. From a developer's standpoint, this is a classification model. You'd feed it an image, and it would output a probability. Say, 0.9 for real or 0.1 for fake. It learns to become incredibly good at spotting the subtle imperfections in the generator's creations. Here's where the magic of adversarial learning happens. They learn through a continuous feedback loop. 1. Generator creates fakes. The generator takes its random input and produces a batch of synthetic data, e.g., fake images. 2. Discriminator gets a test. The discriminator is then presented with two types of data. A batch of real data from a genuine dataset you provide, and the * fake data from the generator. 3. Discriminator makes a call. The discriminator's job is to label each piece of data as either real or fake. 4. Feedback and improvement. Based on how well the discriminator performed, both ICE receive feedback, using techniques like backpropagation, which is how neural networks learn from their mistakes, to adjust their internal code or parameters. This game isn't just one round. It's thousands, even millions of rounds. * the generator's learning. If the discriminator easily spots the fakes, the generator knows it needs to improve. It learns from its mistakes and adjusts its processes to create more convincing fakes next time. Its goal is to become so good that the discriminator guesses real for its fakes most of the time. Asterisk the discriminator's learning. If the discriminator gets fooled by a fake, it learns from that error. It refines its ability to detect subtle differences, becoming a sharper critic. Its goal is to always correctly distinguish real from fake. This continuous, competitive feedback loop pushes both models to become incredibly sophisticated. The generator evolves from producing blurry, unrealistic outputs to generating data that is almost indistinguishable from real-world examples. So, what can these AI forgers and detectives achieve once they've mastered their game? A lot. Generating realistic images, creating AI-generated faces of people who don't exist, realistic landscapes, animals, or even anime characters, art and design, producing unique artwork, generating new fashion designs, or even creating realistic textures for video games. Image-to-image translation, changing a photo from day to night, turning sketches into realistic images, or converting a horse into a zebra. Yes, seriously, data augmentation. For developers, if you have a small dataset for another AI project, a GAN can generate more realistic training examples to boost your model's performance. Deepfakes. While sometimes controversial, GANs are behind the technology that can generate highly convincing fake videos or audio of people, showcasing their powerful generative capabilities. As a developer, you're the architect of this entire system. You're not manually teaching each AI, but setting up the environment for them to learn. Designing the brains. You choose and configure the neural network architectures for both the generator and discriminator. Deciding how many layers, what types of neurons, etc. Defining the rules of the game. You implement the loss functions that tell each AI how badly it performed, and the optimizers that dictate how they learn from those mistakes. Providing the training ground. You curate the real dataset that the discriminator uses to understand what real looks like. Monitoring and tuning. You'll monitor the training process, analyze the generated output, and tweak parameters to guide the GAN towards producing the high quality, realistic data you're aiming for. It's like coding two complex, interdependent systems that evolve through competition. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.